right, so today's section is called inverse functions. So we're going to learn how to find an inverse function, how to verify something's an inverse function, how to use function notation to find things from graphs and from charts and all sorts of stuff like that, okay? So first of all, what is an inverse function? The inverse function is the reverse mapping of a function. So whatever your original function is, we reverse the x and y's. If we're looking at coordinate points, we'd switch the x and the y's. If we were looking at a graph, we would switch the x and the y's. If we're finding the equation or the inverse of the equation, we literally switch the x and the y's. The inverse of a function can be found by switching the input and the output. So x and y, same thing as input and output, okay? And the way you name an inverse is with the little notation that has that -1 as its exponent. So if my original function is f of x, then the inverse is named f -1 of x. If the inverse, or the original was like g of x, it'd be g -1 of x. The function and its inverse are symmetric to the y equals x line. So if I have on my graph two like graphs, and I can draw the y equals x line, which is going to cut right through the first quadrant and the third quadrant, and I fold it along there, the inverses should overlap. And to check to see that something is the inverse, you can find the composite of that function and its inverse in either order. So I can find f -1 of f, or I can find f of f -1, and they would both simplify to just x. So if I took one and plugged it into the other, then what should be left after I simplify it is just x. To find the inverse when you're given an equation, so you could start with something that says like y equals 3x minus 1. The first thing you're doing, actually it would say f of x equals 3x minus 1 because it would be a function. The first thing you would do is replace f of x with y, so it would be y equals 3x minus 1. Then we will literally switch the x and the y variables. The x becomes the y becomes the x. If there's more than one of them, we do it to all of them. And then we solve for the new variable, or the new y. So this, obviously, the steps involved after this will change depending on what type of equation it started with. This one's a linear equation. So I'll add the 1 to both sides. I'd get x plus 1 equals 3y. And then to isolate the y, I would divide by 3. So y would equal, I can leave it as x plus 1 over 3, or I could rewrite it if I wanted to graph it, let's say, as 1/3 x plus 1/3. And then the last step, but a very important one, is you have to replace the y with f -1 of x, because this is no longer the same equation. It is its inverse. So you have to replace y with f -1 of x and then set it equal to whatever it's equal to. So that could be x plus 1 over 3 or 1/3 x plus 1/3. So change the f of x to y. Switch the x and the y, solve for the new y, and then swap the y back out for f -1 of x. You do it. So find the inverse of each of these. All right, so here's the first one. First thing I did was replace f of x with y, switch the x and y, solve for the new y, and then replace the y with the f -1 of x. So if it's open-ended, obviously either of those answers are fine. You can either do -1/3 x plus 7 over 3, or you could keep it together as -x plus 7 over 3. If it's multiple choice, you'll only see one of them, okay? Now, what I said on the slide before, but I want to reiterate because it's going to show up in the homework, is how could I show that these are inverses of each other? So if it said, here's f of x and here's g of x, show that one is the inverse of the other, then you would have to take one and plug it into the other and show that it simplifies to x, and then reverse it. You have to do both. So if I was to do that here, it's also a way you could check your answer, but there are going to be questions that simply say show or verify, and that's what you have to do. So if I did f of f -1 of x, then what I'm doing is I'm going to take the second one just because it's already put together. I'm going to take the f -1 of x and I'm going to plug it into the x of f of x. So I'd get 7 minus 3 times -x plus 7 over 3. And then these cancel. 7 minus a -x plus 7 becomes 7 plus x minus 7. And then the 7 and the -7 cancel out and I get just x, which is what should happen if they are both inverses. And if I reversed it, if I found f negative 1 of f of x. Now I'm taking the f of x and I'm plugging it into the f negative 1 of x. So it'd be negative 7 minus 3x plus 7 over 3. And I'd get negative 7 plus 3x plus 7 over 3. The negative 7 and positive 7 cancel out, and the 3's cancel out, and I get just x. So if it said verify that they're inverses, I have to do both. Obviously, if you're just doing it to check, you could do one. You could do both. It doesn't matter, okay? But if they are inverses, then one will cancel with the other to leave you with just x. Questions so far? Okay, so now go to B. So I'm going to change it so it's y equals 1 over x plus 2. Then I'm going to change it so it's x equals 1 over y plus 2. What's one way to solve this? Because there's more than one. What could be my next step? I can multiply by y plus 2 on the bottom. Or to get it out of the bottom, y plus 2. I could get x times y plus 2 equals, this would cancel 1. And then I could distribute the x, or I could divide both sides by x. Y plus 2 would equal 1 over x, and then subtract the 2. Oh, this is x, sorry. Minus 2, and I would get y equals 1 over x minus 2. And then I have to make sure I make it f negative 1 of x equals 1 over x minus 2. Or from here, I could have distributed. So x, y plus 2x equals 1. And then I could have subtracted the 2x. 1 minus 2x, and then divided by x. So this is also an acceptable answer. Okay. Both of those are fine. They're the same thing. This is just simplified. That one's just simplified and this one's not. But it doesn't matter. Questions? Okay. So first thing is finding the inverse. Second thing is identifying if something even has an inverse from the beginning. So the question will be, does it have an inverse or is it invertible? Okay. And what you're looking for is the y values cannot repeat with a different x. If you remember this when we test for a function at the very beginning of the year, the x values couldn't repeat with a different y. Now it's the other way around. The y value can't repeat with a different x, okay? And the visual test on a function is the vertical line test, right? We draw vertical lines. If it hits it at more than one point, it's not a function. To see if it's invertible, it's a horizontal line test. If the horizontal line hits the graph at more than one point, then it's not invertible, meaning it can't have an inverse, okay? It's also called one-to-one. So if you see invertible, one-to-one, or has an inverse, all mean the same thing. So if it fails my horizontal line test, we would say it's not one-to-one or it's not invertible. But if it says on an FRQ, y is, like, explain your answer. So if my answer is it can't have an inverse or it's not invertible, and it says to explain, you cannot use the words it fails the horizontal line test. They won't give you the point. You have to use this explanation. Each output is mapped from a unique input, okay? So you have to use this verbiage. If I say that it's not invertible, okay? If I were to say it is invertible, or it is one-to-one, or it does have an inverse, then I would say each output is mapped from a unique input value, okay? So if they're not, it fails, it can't be inverted. If it does, then you can have the inverse, and then typically you would find the inverse. So each output must be mapped from a unique input value. All right, so example 2 says find the inverse function of f. The only one on here. F of x equals x squared plus 3, where x is less than 0. So before you get started, think about why this part of my statement is here. What does the graph of x squared plus 3 look like? Nope, x squared. It's a parabola. What's the plus 3 doing? Shifts it up 3. This would be the graph of that, yes? Yes? In a second. Would this pass your horizontal line test? No, this would not be invertible, which is why this part is here, Because if I say I only want the part of this graph where x is less than or equal to 0, I ignore the whole right side of it. And now, does that pass your horizontal line test? Yes. So what you need to understand is if there is a restriction, why is the restriction there? You don't really have to do much with it. You'll see at the end how it applies. But you won't really have to do anything with it. You'll still solve it the same way. But understanding why it's there is what's important. Because without that, this is not invertible. Okay? With it, it is invertible. So first step, make it y equals x squared plus 3. Second step, switch the x and the y. And then I want to solve for the new y. So x minus 3 equals y squared. And then what do? What do you have to do when you square root? Put a plus and minus. Y equals plus and minus the square root of x minus 3. But let's think about what that does. This means there's two square root functions, right? What kind of translations are on my square root functions? If it's x minus 3 underneath, shifted to the right 3. So positive square root x plus 3 would look like this. Negative square root x plus 3 has what impact? What's the negative on the front?
Reflection.
Flips it upside down, right? So does this now pass my vertical line test? No. So if it is invertible, they call it 1-to-1, which means for every x there is one y, and for every y there is one x. So this fails my vertical line test, which means it's no longer a function. So by saying up here, I wanted only where my x values are less than 0, now switch your x and your y in your mind, and that means I really just want where my y values are now less than or equal to 0. So which of those are you going to keep? Only the negative square root of x minus 3.
Why'd you add 3 instead of
Why?
Is it a horizontal shift?
Yeah, but it's opposite, remember? So if it's minus, it shifts it to the right.
Okay, it's a horizontal.
Yep. So does it make sense how we switch this? Everybody good on that? Like if that had said greater than or equal to 0, if my initial function is only good where it's greater than or equal to 0, the x values, then on my inverse, what's going to be greater than or equal to 0? If on my initial I look at the x, on the inverse, the y's are going to be greater than or equal to 0, and I would have only kept the positive. Make sense? Okay, good. So it has to pass, in order for it to be an inverse, it has to pass both vertical and horizontal line tests. So if it had said x is greater than or equal to 0, I would have kept the top one, right? I would have kept the positive one. The other thing, listen so you don't get confused. The other thing on the homework is sometimes it will add the domain restriction to here. So like when you get to AP Classroom, you're going to see questions and then you're going to see a domain restriction on there. Well, this is underneath the square root. So is there a domain restriction? What has to be true? What's under it has to be positive. So greater than or equal to 0, right? So x has to be greater than or equal to 3. So you'll also see with a domain restriction, x greater than or equal to 3. So the restriction on the initial x affects the y on your answer. But your new answer might also have a domain restriction if it's got a square root or if it's got a denominator. Okay, now we look at it from a chart. So this literally says use the values to find the values of the inverse. This is my initial function. The x values are my x values. The f of x values are my y values. So what do I do to get the inverse? Switch it. So the x is still here, but now this becomes f negative 1 of x. And the x and the y get switched. 6, 1, 10, 2, 14, 3. So I could do it with coordinate points. I could do it with a graph. I could do it with a chart. All right, example 4 says an invertible function p has an x-intercept of negative 5, 0, and the graph includes the ordered pair of 4, 9. Identify 2 pieces of information that can be correctly stated about p, negative 1 of x. So if I start with the x-intercept of negative 1, 5 of p, what does that mean is true for p, negative 1 of x? There's a y-intercept of 0, -5. Switch your x and your y, right? And if the ordered pair 4, 9 is on P of x, then what ordered pair is on P -1 of x? Good. Switching our x's and our y's. Still good? Yeah. So if even if I didn't look at like the words x-intercept and I just knew that coordinate point was on there, if this is on my original, then the switch is on my inverse, right? Which would be 0, -5. And my x is 0, which makes it a y-intercept. But everything true about my x is going to now be true about my y. You're welcome. All right. Now we're putting what we did yesterday, oh, not yet, yeah, a little bit. What we did yesterday and today together, right? We're going to use function notation mixed in with inverse function notation. So it says use the values to find the following. Find the value of f -1 of 3. So here's two options. One is take this whole chart and rewrite it switched. Okay, so if I do that, I create f -1. So if I do that, x f -1 of x, I'm going to switch them. So -2, 3, 5, 1, 2, 3. Now, anytime I want to use my f -1s, I'm going to use the pink chart I just wrote. And anytime I want to use my f of x, I'm going to use the initial chart. So if A says find the value of f -1 of 3, what's f -1 of 3? 2. I go to where f, on my pink chart, where the x is 3, and I find the f -1, which would be 2. The other way to do it is instead of rewriting it, reverse this in your mind. If I'm saying f -1 of 3, I'm going to where the y is 3 and I want the x value. You don't have to rewrite it. If it confuses you, rewrite it. But if it says f -1 of something, that means that what's in the parentheses is now your y and your answer is your x. Okay? Does that make sense? All right. If it confuses you, rewrite it. All right, go to B. So f -1 of -2 is either from my first chart when my y is -2, so my answer's 1, or from my new chart where my x is -2 and my answer's still 1. Plus 3 times f of 2. There's no -1 there, so I'm using my original points. What's f of 2 on the original box? 3. So this is times 3. This is 1 plus 9, which is 10. So now that we've done composite functions and inverse functions, you're going to see these start to build. It could say find f -1 of f of g of 3. And you might have a box for g of 3 or an equation for g of 3 or a graph for g of 3. You'd find that. You'd then go to f of x and use the chart. And then you'd go to f -1 and use the chart as well. Okay? So they're going to build all these things together. Correct. So if you're only using the original chart, then my f of, without the -1, I'm looking for whatever's inside the parentheses is the x, and I'm giving the answers the y. If I don't change the chart and I just use the original one and it says f -1 of x, then what's inside the parentheses is actually my y, and my answer is my x. If you recreate the chart, then you're using your new chart only for f -1s. And what's inside the parentheses, the x on that -1, and the answer is the y. You're welcome. This is almost guaranteed an FRQ on your AP exam. Some sort of function mixed with what we did yesterday. A chart, an equation, a graph, and then it's going to piece them all together. And there will be inverses and composite functions built in.
Let's say you had like that actual question.
You would need a g of x.
So they would have to give you...
Yeah, they would give you like g of x is an equation or g of x is a graph.
Okay.
Yep.
And then they would give you something for...
And then your f of x, you would use that.
Yeah.
And then your f -1, you use that, or you would reverse it. Yep. All right. Last one, no, second last one. This one says, which of the following intervals can be used to create an invertible piece? All right, so we're looking at this graph, right, for a visual section in which it could be invertible. What does it mean on a graph? How do I know if it can be invertible? It's got to pass the horizontal line test. So the first part says from negative infinity to positive infinity. The whole thing. Can I pass a horizontal line test a line through there and avoid hitting more than 1 point? No. So that one definitely doesn't work. Okay. Second one says from 0 to 1. So if I only go from negative infinity. Sorry, from negative infinity to 0. So that yellow section. Can I pass horizontal line test through there? No. So that one doesn't work. Then it says from negative infinity to negative 8 or 0.84. So I'm all the way to here, okay? Just that first curve. Would that pass a horizontal line test? Yes. So this one is good, okay? From 0 to 0.84. So from 0 to 0.84 is all that section. Would that pass? No. From 0.30, positive 0.307 to 0.84, would that pass? Yes. So those are the two sections in which you could pass a horizontal line through, and it's not going to hit more than once. Questions? Okay. Last one. It says, given f of x equals x squared minus 3, where x is less than or equal to 0, so that's giving you the restriction, answer the following. Graph f of x, find its domain and range. Graph f negative 1 of x, find its domain and range, and then find f negative 1 of x algebraically. So start with f of x with the restriction. Now what does this graph look like? What's x squared minus 3? Parabola shifted down 3. So in its entirety, without the restriction, it will look something like this, right? But it says where x is less than or equal to 0. So it only wants from 0 and then left of 0, okay? What's the domain on this?
Negative infinity to 0.
Good. Negative infinity to 0, bracket or parentheses? Bracket. What's the range? Good. Bracket, right? Well, I already wrote it, but yeah, bracket. Now graph f negative 1 of x before we find it algebraically, which means I literally need to take some points and switch them. So to do that, I need at least one more point on this curve, okay? So we know that if there's no stretch on a parabola, that from that vertex it goes up and out 1, I could use that one. Or I could plug in. I could plug in negative 1. I could plug in negative 2 to see what's happening. Negative 2 squared minus 3 would be 4 minus 3, which is 1. So now I have a more accurate picture of my graph, which I need if I'm going to flip these before I find the equation. So here, and then negative 2, 1. So there's a better graph of my initial function. Now every coordinate point that I just plotted, I'm going to switch to get the inverse. So this point was negative 2, 1. This point, negative 1, negative 2. This point, 0, negative 3. Those are for your parent function or your initial function, f of x. Now for f negative 1 of x, I'm going to switch all those x and y values. I get 1, negative 2, negative 2, negative 1, negative 3, 0. Okay, and then because the x had to be greater than 0, less than 0 here, the y has to be less than 0. Okay, now if we were to check, we could draw a line through y equals x. And if we folded these over, they would overlap. Okay, thank you. Domain is negative 3 to positive infinity. Range negative infinity to 0. And then the last thing says find f negative 1 algebraically. So I'm going to take my f of x. I'm going to make it y equals x squared minus 3. Flip them so it's x equals y squared minus 3. Add the 3. X plus 3 equals y squared. Square root. normally plus and minus, but because we only wanted the x to be less than 0 here, we want the y to be less than 0, which means I'm going to pick which one? The negative. So this becomes f negative 1 of x equals negative square root x plus 3. Which should match your graph. This is a square root function, flipped over the x-axis, shifted left 3 units. Questions on anything we talked about today? Anything inverse related?